broke actually on that day. Like you see, if you have two electrons, the movement of the two electrons is explained by a fully headed arrow. There's a fully headed arrow, the movement of two electrons, and the movement of a single electron is explained by a half-headed arrow like that, or it's also called a fishhook arrow, right? And then if a bond is evenly broken, if the bond is evenly broken, we say it's homolytic bond breakage. If it is not evenly broken, meaning two electrons will end up on one atom, that is called heterolytic bond breakage. So you can categorize all these reaction mechanisms into four types. We are going to look at this basic reaction mechanism, very basic reaction mechanisms. First one is called the substitution. Then the second one is called addition. Third one is called elimination, and the fourth one is called rearrangement. So I will start from there. First one is called substitution. Substitution. So in substitution, what will happen is, like, the word itself will tell you what it means. Substitution means, now let us say you have A and then B, something like that, right? Now, if you do this reaction, whatever the reaction that you do, let us say you had C here. Now this B will completely get removed and it is replaced by C. So it's a substitution. Substitute. Now in your, like, in your university, you might have substituted lecturers, right? One day the lecturer doesn't come, and maybe rather than canceling the lecture completely, he or she might ask someone else to take the lecture, substituted lecture or substituted teacher. It's like that. So substitution. Instead of one group, there's another group. So that's called substitution, right? One group instead of the first group, instead of B, C will take over. C will take over. So that is called substitution, right? First one is that. Now the next one is addition. Addition means, now the word addition means you are introducing a entirely new group. Now, for example, like, you're in your house, you might, like, you might have a house, like, and then your parents might think, okay, like, we want to add another room to this house. So newly built, like, it's like that. So now let us say you have a group like A double bond B, and then let's say you are reacting this with hydrogen, some gas, hydrogen gas. Now the double bond will break, and then all the old atoms are there. Now new atoms are completely added. That is called addition. So you have two things now: substitution and addition. Substitution is one material is removed and another material is replaced instead of that. That's substitute. Addition means all the old atoms are there, but new atoms are being added. Addition. Substitution, addition. Then the next one is elimination. Elimination means, now you know what is elimination. Elimination means like, completely removed, right? Elimination is that. Like, if you look at, let us say you have a and a B, and then let us say that A has a hydrogen, and then this B has some other atom, like, let us say chlorine, something like that. It's completely removed. This molecule is completely removed. That is called elimination. Yeah, removal, elimination. So you get A and then B. One complete molecule is completely removed, elimination. So now three things: substitution, addition, and elimination. Substitution means you have one group, and instead of that group, you introduce a new group. Substitution. Addition means all the old atoms are there, like, but you introduce new atoms also. Addition. Elimination means one molecule is going to completely leave, right? And then you get a brand new molecule. That is called elimination. And the third type of reaction is called rearrangements. What is that? Rearrangements. What is rearrangement? Rearrangement means the carbon skeleton. We are talking about organic chemistry. So the carbon skeleton is completely changed. Carbon skeleton is completely changed. Now, for example, let us say you have a carbon skeleton like that. Like, let us say you have a carbon skeleton like this, and then something like that. And then when you add this material, you get the carbon skeleton like this, right? You can see carbon skeleton has completely changed. Earlier, the carbon skeleton didn't change, right? Now the skeleton has completely changed. So these are the four types of mechanisms that you have. You have the substitution or basic mechanism, substitution, addition, elimination, and rearrangement. Substitution means you replace it with some other group. Addition means you add two multiple atoms newly. All the old atoms are there, but then new atoms are being added. Elimination means some of the old atoms are completely removed. Elimination. Rearrangement means the carbon skeleton is now changed. Carbon skeleton is now completely changed. So that is what you have as rearrangement. So first of all, we will look at some of these examples. How do you write these mechanisms? How do you write the mechanism? That's what we try to kind of work out. So first one, we'll look at substitution, right? So substitution. Now look at this example. If you have an example like this, now for example, let us say CH3, CH2OH, right? And then let's say you add PCl5 to this and then heat it. And they say, okay, CH3, CH2, Cl is formed. Now, can you see that there is a substitution? Now here, look at this one. This group here, here there's this OH group. You can see that OH group. Now it is replaced with a Cl group. Like, completely new group that is there. Like, that Cl has given an arrow somewhere there. So Cl, right. OH is completely replaced with Cl. That is called a substitution. So this one is replaced with a Cl. You can see that replaced with a Cl. Now let us take another example. Now, for example, let us say you have a CH3, CH2, C double bond O, H, right? I will say not double bond O. We will change it slightly. Let us say we have this compound H here, and then there is this Br. And then if you add sodium hydroxide, and they have given this compound CH3, CH2, let's say CH2OH. Now look at the difference here. Now you can see the difference is you have a Br here. Look at that. That Br is the one that has changed to OH. Otherwise, the carbon skeleton is the same. CH3 is there, CH2 is there, the next CH2 is also there. But then that CBr, the Br is gone, it's replaced with OH. Do you see that? So that is called a substitution. Look at this, that is called a substitution. This one is a substitution. So I would at least want you to understand if a reaction is given, the reactant and the product is given, like, can you tell me whether it's a substitution, whether it's a elimination, whether it's a rearrangement, whether it's a addition? Those kinds of things I want you to kind of work that, like, understand. So how do you work this reaction here? So this is what happens. If you look at this one, CH3, CH2, and then you have CH2, this is Br. Br likes electrons more. So therefore, it likes to withdraw electrons towards itself. And the carbon has a positive charge. So when you look at this bond, carbon-bromine bond, this is like an electron cloud. the carbon, bromine, there's an electron cloud forming the carbon-bromine bond. Bromine likes electrons more. So therefore, it's withdrawing electrons towards that side. So this is, we say, electrons are withdrawn. So this is shown, like, if you want to show that, you show it like this kind of a small minus sign. So small means, you see, there's a difference, delta, right? Delta minus. Delta minus means there's a small minus sign onto bromine because it's withdrawing electrons. So if it is withdrawing electrons, carbon loses its electrons, so it has a small positive charge, right? So small minus, small negative charge. Why do you see that negative charge appearing? This negative charge appears because of the electron withdrawal, right? So now what will happen is this, you get CH3, you get CH2, and then you get CH2Br. Now you're adding sodium hydroxide. So this is delta minus, this is delta plus. Now you add sodium hydroxide to this. Hydroxide, OH, there's a negative charge. So now this negative charge attacks onto this carbon. So you can understand a curly arrow represent 2 electron movement. So hydroxyl gives those 2 electrons to that carbon. And then this carbon-bromine bond will break towards the bromine and it will give you this compound, CH3, CH2, CH2, and then OH, right? And then it'll give out Br minus. So here, Br is replaced with OH. So we say it's a substitution reaction. That is what is meant by a substitution. Is it clear? Now, if you look at, now let us say someone else, like, asks you to write this mechanism. How do you work on this? Now, for example, let us say CH3, CH2, let us say CH, Br, CH3. And then you've been asked to write the mechanism with hydroxide, with sodium hydroxide. What is the product? CH3, CH2, nothing happened to the carbon chain. CH3, instead of the bromine, this hydroxyl take over. So that's it. Would you be able to write the mechanism? Try that out. I'll give you 1 minute to work it out. See whether you can write the mechanism. Is there any way that you can write the mechanism? Try that out, will you? CH3, CH2, CHBr, CH3. You had hydroxyl to it. Would you be able to write it down? Now that can become a little complex also. But then I want you to kind of work that out in a most simplest manner. Hydroxyl. So you can see here minus. You have a minus charge on that oxygen. So electrons will move from that oxygen to the bromine. Why? Because bromine is delta minus and that carbon is delta plus. So delta plus, positive charges. Now hydroxyl is the one that will attract towards it. So that carbon-bromine bond will break and you would get this kind of a compound. And you have Br minus releasing. Is it clear? Everybody understood that. So that's called a substitution reaction. Substitution reaction. These are mainly called nucleophilic substitution reaction. But at least I want you to recognize that it is a substitution that is taking place. Like the Br is replaced with OH. That is what is called a substitution. Right? So that's that. Now, if someone asks you to write this kind of a mechanism, would you be able to work it out? Now, for example, let us say you have CH3, CH, 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 And then let us say CH. Let's say you have a Br here. This is also CH2. You can see it's a cyclic structure. Like you can draw it like this. And then you have a CH3. Right? And then here you have a Br. If somebody asks you, can you write the mechanism with the sodium hydroxide? Would you be able to work it out? Sodium is this plus, hydroxyl is minus. So where can it attack? This hydroxide can attack onto that carbon. So remember, bromine is delta minus, carbon is delta plus. So it should always attack the positive charge. So the electrons should begin with the place where you have electrons. This is where you have more electrons. And this is where you have less electrons. So you draw the arrow starting from more electrons to less electrons. So meaning that is where the electrons are moving, right? Electrons are given by hydroxy. The electrons to give, it should have electrons. So that is where you begin. And like you can see from the center of the bond to the corner there. So that will give you new compound. There you have a CH3 over here, and then you get OH. Like there's stereochemistry, all that, how three-dimensionally appear. But I wouldn't worry about that at the moment. We are looking at only the what do you mean by a substitution? Is it clear to you, everyone? If you're okay with that, then we can look at the next type of reaction, addition. What do you mean by an addition reaction? So you can say what is an addition reaction. Addition reaction is a reaction where you can add the material. Addition, like new atoms are being added. That's what you mean by an addition reaction. Now think about a compound like this. CH2, you have a double bond CH2. This kind of compound is called an alkene, right? Alkene. Now let us say you have a molecule like bromine. Right now, bromine is a little bit of a complex example. That might not be the first choice. We will take HBr addition, right? CH2, double bond CH2, and you are adding HBr. This is called hydrobromic acid. Right? Hydrogen bromide or hydrobromic acid. Now, if you look at HBr also you have this delta minus, delta plus. Bromine is delta minus, and then hydrogen is delta plus. Delta minus and delta plus. Why bromine is more electronegative? It's withdrawing electrons towards it. So hydrogen doesn't have that capability. So because of that, hydrogen gets a positive charge, bromine gets a negative charge. Now, the CH2, like, that's a very symmetric molecule. Now, if this is positive, this becomes negative and this becomes positive. Like, this works like a kind of magnet, like kind of this kind of thing. Now, for example, CH2, like, there's an electron cloud. Yeah. On this side, like, you have an electron cloud like that, covering entire carbon, two carbon atoms, there's an electron cloud like this. Now, if you bring the HBr from this side, right, this is delta minus, this is delta plus, this is electron division. It likes to gain electrons. So how can it gain electrons? It will deform the electron cloud. It will minimize the electron cloud from this side. And this is maximize the electron cloud to this side. It attracts towards this side, right? So we get a delta positive delta negative character on this side, and then there's a delta positive character on the other side. Clear? So now we need to show how the electrons move, right? Electrons will move from the electron rich to electron poor, right? So this is where it is reached. It breaks towards this side, right? And then it breaks onto that, right? So this is the electron poor direction. This is the electron rich one, huh? And this is the electron poor one. Electron poor. So electron flow take place from electron rich to electron poor. So that goes on to that. And the bond breaks. Now see what happens. When that happens, like you get CH2 and then CH2 and you get a new hydrogen. This is already CH2, like this hydrogen you get, right? So that becomes CH3. And this carbon becomes a positive charge. Why? Because it had those two electrons. Look at that, this electron and this electron. These two electrons that is in the bond taken from one side and is given to the other carbon. So it is losing one electron. Because it is losing one electron, it gains that positive charge. Very unstable. Doesn't like to be like that. But then immediately you have this bromide. This bromide will attack onto that. And then it gives you this new product. CH2, you get Br, CH3. Now look at the molecule, what has happened? All the old atoms are there. You had two carbons, both carbons are there. You had two hydrogens either side, both contains those two hydrogens. But if you look at the molecule, you can see that newly introduced HBr. So you let me show you carbon-carbon. This is the hydrogens that you already had. These are the hydrogens that you already had. And there was a double bond. Now, what has happened to the double bond? Double bond is going to break. Right? It's gone. Double bond is gone. On one side, you get the hydrogen. Right? I should have drawn it in a different color. Let's say you get hydrogen. On the other side, you get bromine. So you can see a newly introduced atoms are there. That is called addition. New addition to the molecule. Clear? Look at this example. Think about this kind of a chemical compound. CH2 double bond CH2. And let us say you add hydrogen. Now, if you can't just add hydrogen, you have to have a catalyst also. Let us say, just say platinum. Platinum is a catalyst, right? It'll help the reaction to take place. So look at the compound, you get CH3, CH3. All the old atoms are there. New atoms are being added. Right? You have carbon, you have a hydrogen, and then on the other side also you have two hydrogens. Now you can see in order to get CH3, you have to add another two hydrogens. These two hydrogens are the hydrogens that is being added. So that is called an addition reaction. What about this one? Right, okay, now before going to the next one, I will give you two reactions. Tell me whether it is addition or substitution. Nah? What about this reaction? CH3, CH, double bond CH2. And then let us say you add bromine. Right, CH3, CH, Br, CH2, Br. Is it addition, substitution? Think about this one. CH3, CH, double bond, CH. And then let us CH2OH. Can you tell me whether it's a addition reaction or a substitution reaction? First one. First one, can you tell me whether it's addition or a substitution? Second one, is addition or a substitution? First one, what do you think? I'll give you a few minutes to think about it and give me an answer. First one, is it addition reaction or a substitution reaction? What do you think? It's a addition reaction. Yes, somebody is right here. Addition reaction. You have bromine, newly, the group is newly added. All the old atoms are there. It's an addition reaction. What about next one? Is it an addition reaction, substitution reaction? Like we discussed only two, so it's either addition or substitution. But I might have given two additions, or maybe one addition, one substitution, or two substitutions. Definitely not two substitutions because one is addition. So I'll recognize that. What about the other one? Is it addition or is it a substitution? Yes. Yeah, you're right. Substitution. Yes, you're right. But why do you call it a substitution? Can you tell me? What is the reason to say that it is a substitution? Can you give me a reason? Simple reason. If somebody asks you, why do you call it a substitution? What is the reason? So say that that's a substitution. Why do you call this? Yeah. So you can see that, yes, exactly. Very good. Yes. Here you have a Br here. Br is replaced with OH there. So because it is the Br being replaced with a OH group, it's called a substitution reaction, right? Is it clear? If somebody asks you, okay, can you write the mechanism of the first one? First mechanism? How do you write the mechanism? CH3, CH, double bond CH2, right? So this is delta minus and this is delta plus because this CH3 group can push electrons. When that happens, that entire electron cloud gets pushed onto this side. And then you have bromine here, Br. This is delta minus and this becomes delta plus. So now what will happen is this bond will break over here and then this bond will leave, right? CH3, you get CH plus, and then you get CH2Br plus Br minus. But at least now after that, there's some other steps that is there. But then cyclic bromonium kind of thing. But then I wouldn't worry about that too much. So that'll attack, right? So CH3, you get CH, Br, CH2, Br. So it's a addition type reaction. Addition type reaction. So that's why it is called addition. Right? Can you try to write the mechanism for the second one? This one. If it is a substitution, you all know how to get the substitution. How can you write the mechanism for the substitution? Let's say CH3, CH, double bond CH, and then CH2Br. And then bromine is delta minus, and that carbon is delta plus. And you have a hydroxyl ion. So now what will happen is this hydroxyl, change the color, this hydroxyl attacks onto that carbon, and then carbon-bromine bond will break. When that breaks, you get CH3, CH, double bond, CH, CH2, OH. and then get the Br minus. So that is it. Can you write a simple mechanism like that? That's my question to you. Like simple mechanism that would work. Right. So you have the substitution, now addition. Now the next one I want to look at is the reactions which are known as elimination reaction. Elimination, word elimination stands for removal, right? Eliminated from a game, removed from the game. It's like that. So elimination means that. Here also the same thing. Like, a group is completely removed, nothing being added, completely removed, right? There's like, it's not replaced by something else, but it's completely removed. That is elimination. A molecule like water, a molecule like HX, HBr, HCl, that kind of molecule are removed. Not only these, you can have many other groups, but then at least understand, if you look at a reaction, I want you to at least understand whether you can recognize what kind of a reaction is this. Is it an elimination, addition, substitution? Elimination means it is going to completely remove. One example, let us say you have a hydrogen here. There's a hydrogen here. Let us say there's a hydrogen and there's a hydrogen here. Let us say you have a hydrogen on this carbon that will complete the octet there. And let us say also, we will say there's a bromine. And then we add some kind of a material, let us say, what, alcoholic type KOH. Now, as soon as you add this, you would see this H is going to remove with this Br. These two tend to remove, right? They react, they tend to remove. And you get H here, carbon, this is H, this is H, right? So complete molecule of HBr is going to remove. So I will say minus HBr. Now that is called an elimination. That's an elimination reaction taking place, right? Alcoholic KOH, and you get an elimination. There is it's a new molecule, type of molecule. These are called alkenes. We talk about functional groups earlier. This is called, and what is this functional group called? This compound, the class of compound is called, we talked about this. Can you all tell me what is this functional group called? This type of compound. What kind of a group is that? Is it a carboxylic acid? Is it an alcohol? What is this type of compound? What is the type of compound? What kind of a compound is this? It is when you have a alkyl group and a Br, alkyl group and a Br, it is called not an alcohol, it's an alkyl halide, alkyl bromide. And then double bond is called an alkene. Right? But anyway, now let us see how the reaction work. Now let us say you have a carbon, hydrogen, and then you have Br, hydrogen, right? So when you add these alcoholic conditions, right? Not dissolved in water, but alcohol, dissolved in alcohol, what will happen is this hydroxyl will attack the adjacent hydrogen. The bond will break onto this, forming the double bond. This Br will completely leave. And that will give you CH2 double bond CH2. kind of a molecule. Right? Now think about this compound. If somebody asks you CH3, CH2, CH2OH. To this you add concentrated sulfuric dehydrating agent. And you get this compound. Can you see whether it's a substitution, elimination, or addition? What kind of a reaction is this? What is this reaction type? It's an elimination. Yes, exactly. Like, you can see, can you tell me what is eliminated here? Very good. What is eliminated? What is the molecule that is removed? Yes, a molecule that is removed is, you are removing a hydrogen, this HOH. That is what you remove. What is HOH? HOH means what? HOH means water, right? A molecule of water will remove, right? So that is why it's called dehydration. Is it clear? So you can say a molecule of water. Molecule of water is removed. Everybody understood that? Now, for example, let us say, what do you think about these two reactions? Huh? Tell me, how does it work? So I will write down this reaction, huh? CH2. This is the reaction number 1. Right? And then I'm going to say you're adding HBr, CH3, CH2, and then you get CH2, let's say Br. And then can you identify what type of mechanisms are these? First mechanism, this is the second mechanism, this is the third mechanism. Can you identify these 3 mechanisms? First mechanism, is it an elimination? Is it a substitution? Is it an addition? First one is a substitution. Very good. Very good. That's a substitution, right? So it's a, I will write it as substitution. Substitution is that. Because the Br is replaced with OH, substitution. Now tell me the next one, the second one, is it a substitution, elimination, no addition? Second one, what do you think? Elimination, addition, or a substitution? What kind of mechanism is that? Second one. (153), you have answered? There. There's one answer. Ashini says substitution. Others? Yes, substitution is right. Because OH is replaced with a Br. Right? OH is gone and it is replaced with a Br, substitution. Instead of the first group, another group comes in. So it's a substitution. Right. What about the third one? What kind of a mechanism is that? What is the mechanism type? Yeah, yeah, very good. Third one is an elimination. You can see Br is going to eliminate with hydrogen. So it's an elimination. Elimination. Is that okay? Clear? Everybody okay with that? Yeah, right. Then we will move on to the last type of mechanism. The last type of mechanism is rearrangement. Now, in order to look at rearrangement, let me first look at like carbocations and their types, right? Carbocations and then types. Now, what do you mean by carbocations? You know what are cations? Cations are atoms with positive charges. Now, they turns into ions. Atoms, when you remove electrons, you get positive charges. That turns into ions. So, cations are like that. Carbocations are like, you understand carbo means carbon. If a positive charge is on carbon, we call it a carbocation. So what is a carbocation? A species with a positive charge on carbon, right? There are four types of carbocations that are there. First one is called methyl carbocation, CH3 plus. What is this called? Methyl. Then you have primary carbocations, where the positive charge containing carbon contains only one alkyl group. Yeah. One alkyl group is there. Positive charge containing carbon, it is directly attached only to one alkyl group. Alkyl group is like another carbon containing group, like that. CH3 is an alkyl group, right? Now, if there are two alkyl groups attached to the positive charge containing carbon, we call it a secondary carbocation. This is hydrogen. Nah? Secondary carbocation. So you can see here in this secondary carbocation, what you have is you have two alkyl groups. This is the first alkyl group, this is the second alkyl group. Easy to remember. Secondary, two alkyl groups. Primary, one alkyl group. One alkyl group. And then let us say you have another one tertiary, like you can see the pattern. CH3, C, CH3, and then you have a CH3 and then plus. That's called tertiary. Tertiary carbocations. Here, look at this. Now, this is called a primary carbocation. So we give the symbol 1 prime. This is called a secondary carbocation. You can see two alkyl groups are there. So it's given a 2 prime. Like this is the tertiary carbocation, you give 3. Right? So there are 4 types of carbocations. Methyl carbocation, there is one and only one. Methyl carbocations. Then you have primary, secondary, and tertiary. Right? Now, I told you earlier, these CH3 groups that are there, they push electrons. They push electrons. They can push electrons like this. So here you can see, here there's CH3. Here there's a CH3. They will push electrons. Let me, like, make it very light. So this will push electrons. This will push electrons. And this will also push electrons. Here there is only two sides that are there. Now here there is only one side to push electrons. So that effect makes it stable, unstable. So stability comes in, how stable the group is. Stability comes in, based on this. So methyl carbocations are less stable than primary carbocations, less stable than the secondary carbocations, less stable than the tertiary carbocations. More electron pushing power that is there, it becomes stable. It is like this. Now, having a positive charge on carbon is unstable. You don't have 8 electrons. They like to get 8 electrons, so they don't like that. But then CH3 supports. It's like, we are in a problem, some kind of a issue with our life. Some of those things that will happen. And sometimes you have these sleepless nights. And then, but then if there are many friends to support you in difficult times, you are safe, right? So the CH3s are like, those good supporting friends. The positive charge is like the bigger problem that we have. You have three friends to share your sorrow, and that will help you to stabilize. So more alkyl groups you have is better. Like for a carbocation, it's exactly like when you have more good friends around you, it might be even very helpful. It's like that. So alkyl groups for a carbocation is like really good friends, right? So you get this kind of a variation taking place, right? So methyl primary, secondary. It's like that. That is how the stability order takes place, right? Stability order takes place based on that, right? So that's really important. Now, keeping that in mind, let us take one rearrangement reaction. Let us take this one, CH3, CH3, CH3. Let us say you have CH2 OH, right? CH2OH. Now we try to put a little bit of, mix it with little bit of sulfuric, right? H2SO4. Let us say you add a little bit of sulfuric to it. Sulfuric means you have you have H plus. When you have H plus, first thing that will happen is this lone pair will capture the H plus. It will take the H there, right? When you take the H there, see what is going to form. Right? Now you all know CH2, this one is OH, and then H, and then positive charge, right? That carbon-oxygen bond will break, right? Now, when that carbon-oxygen bond will break, if it breaks, can you all tell me what kind of a carbocation would you get? Let me draw that first. So you get CH3, CH3, and you get CH2 plus. What kind of a carbocation is that? You have four options: methyl carbocations, primary, secondary, tertiary. What kind of a carbocation is this? Is it a tertiary carbocation? You can see this. This is only one alkyl group attached. Let me show you that. There's only one alkyl group attached here. This is there, but only one alkyl group attached. Look at the carbocation, carbon containing like, positive charge containing carbon, you have two hydrogens. Do you understand that? You have two hydrogens. There's only one alkyl group. Yeah? There's only one alkyl group. Did you understand that? It's exactly like this. Yeah, two hydrogens are there. So what kind of a carbocation is that? Do you still think that it is tertiary? Or is it primary or is it secondary? It's a primary carbocation. Yes, it's a primary carbocation. Right. Clear? Okay, so that is a primary carbocation. Let me remove some of those drawings that I made. Right? Now it's a primary carbocation. So I'm going to write that as a primary carbocation, like primary carbocation. But then what will happen is now the molecule decide to change its structure, right? Molecule decide to make a CH3 shift. CH3 from this carbon to next carbon, it decides to shift. Now you might wonder why. Why does it shift? We will see. Let us shift the molecule and see how this is going to work. So first CH3 is CH3. Then there is a carbon, there's a CH3. On the other side, you have a CH2 and then CH3. Now the positive charge comes onto this. By moving the CH3, positive charge jumps onto the other carbon. So what kind of a carbocation is this? What kind of a carbocation is that? Don't make mistakes, right? Try not to make mistakes. Try to like tell me the right answer straight away. What do you think? What kind of a carbocation is that? Primary, secondary, tertiary. Look at the carbocation where you have the carbocation. This is the carbocation. This is where the carbocation is. What kind of a carbocation is that? Is it a primary carbocation? Is it a secondary or is it a tertiary carbocation? Now you can see this, right? There's this CH3. There's this CH3. There's this CH3. And there's another kind of alkyl group that is there. So there are three alkyl groups attached. Don't you think that it looks like that? No hydrogens on the positive charge carbon. It's a tertiary carbocation. So this is called a tertiary carbocation. Now tell me what is more stable, primary carbocation or a tertiary carbocation is more stable? Which carbocation is stable? I have given you in green color above. You can see it on the screen. What is more stable? Tertiary carbocation is more stable, I told you. So here the stability increases in that direction. Right. If it is tertiary carbocation, like rather than keeping it in the primary carbocation, it likes to go into the tertiary carbocation. Right? So this reaction, this process takes place really well. Right? So you come to that point. And after that, there's another process taking place, CH3, see the CH3, and there's a positive charge. Now, anyway, the carbons like, molecule doesn't like to have positive charges and negative charges, especially these carbon containing compound. It will remove a water molecule. So that hydrogen is removed, OH removed earlier. This is going to remove, and you get a kind of new molecule. So this is called, what is this called? This is called a rearrangement. So carbon skeleton is completely changed. Look at that carbon skeleton. It's like a cross, and there's a carbon, there's a carbon, there's a carbon, there's a carbon, there's a carbon. There are five carbons, like a cross. You have a OH at the end. But now, if you look at the structure now, you have this kind of a structure, slightly different from a cross. Did you understand that? Right. So that is it. So these are the four different types of rearrangement, four different types of mechanisms that you have: elimination, addition, substitution, and then rearrangements. That's what you have, right? So I want you to kind of look at that. Now, and at the same time, I want you to understand, I've been instructed to have a mid-semester examination for you all. So, mid-semester examination, what is the date that you like to have it? Is it on Friday or Monday? Next Monday or this Friday? Are you ready to do this mid-semester exam? Because there was no contact from your end. We had this trouble, not to have the mid-semester. We keep on doing our lectures, but then now, Dr. Pahalagedara is there. Like he has instructed me to have a mid-semester exam. So are you all ready for Friday? No answer means you are ready, huh? Right? No answer means I will take it as you are ready. I will send you the paper. So next Friday, this Friday. So what is today is 18th, 20th. Okay, so decided then everybody decided. Some say next Monday, right? Monday, everyone then. Can we have it on Monday? Oh, okay. Right, Monday. So Monday, like I want you to write down the topics that I will be examining, right? Monday, right? So next Monday. So we will go with atomic structure, right? Bonding, Lewis structures, bonding, atomic structure, Lewis structures, bonding, balancing equations, and then calculations related to moles and concentrations. So, what are the topics? First topic is atomic structure, Lewis structures and bonding. Then balancing equations, calculations related to atomic structure and concentration. Not atomic structure, calculations related to concentrations and moles. Is it okay? Would you be able to look at those things? Next Monday, right? I'll talk to sir and I will see what we can do, right? So make sure to be ready by Monday, right? So Monday, I will send the paper. Okay, right? Okay, thank you, right? Okay, good night. Thank you very much. Thank you. Right, I will. Okay, I will end the meeting. Right, thank you.